All right, let's talk about how to prove triangles congruent. This is for worksheet 4 in chapter 4, and here we go. So you should know activity we did in class of what criteria establish congruent triangles, and here they are again. So the first is angle, side, angle. These letters are in order for a very specific reason. This means a pair of angles, a pair of sides, and a pair of angles. Notice how the S is in the middle of the two angles, and here the side is touching both angles. That's how you know it's angle, side, angle. Now, if I didn't have that, the left angle and that side, if I had this side instead, for instance, this angle doesn't work. It would have to be that angle. Okay. And then same thing, if I had this side, it would have to be that angle. So the side has to be touching both the angles for angle, side, angle to be the criteria. Now let's talk about angle, angle, side. So again, same thing kind of, two angles and a side, but in this case the side has to be only touching one of the angles. So it wouldn't be the side here. In this circumstance with these two angles, it would be this side or this side, because either of those sides are only touching one angle at a given time. So that's what angle, angle, side would look like. For side, angle, side, this is going to be very similar to angle, side, angle. It's two sides with an angle in the middle. So something like this. So side, angle, side. Two sides, angle touching both the sides. If I had this side here and this angle, we would have this guy. And side, 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 that one's pretty self-explanatory. All three sides are equal. There is one other one called HL. HL stands for hypotenuse leg. Because it stands for hypotenuse leg, it can only exist inside of a right triangle. And it basically says that the hypotenuse is congruent to a leg. The reason being, because of the Pythagorean theorem, if you know that the hypotenusi, are equal and two legs are equal, this third leg has to also be equal. There's no way for it not to be because of Pythagorean theorem. So as long as you have the hypotenuse and one of the legs in a right triangle only, because that's the only time a hypotenuse exists, you have congruent triangles as well. So that's another one to know. Which ones did not establish congruence? Well, that would have been angle, 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 because let's say, for instance, I had an equilateral triangle. I could have another equilateral triangle that looks a heck of a lot bigger, but still has 360-degree angles. So that's why that one doesn't work. And then side, side, angle. I'm hoping that you were able to see this in class, how the angles, because they're not attached to two sides, it can go any way. So for instance, because it's just the two sides and an angle, here I can connect this side from this way, but over here, because this angle isn't hinged, I could have a side any of those. So that could connect at any point. Those are going to be two different triangles. So I could have hit here, etc. So that is the two that don't work. And please remember, this spelled forwards or backwards is still wrong. Okay, so let's go over some examples. Are the triangles congruent, and what's the criteria? So I'm looking over here and I see vertical angles, which we can always give. Just wanted to throw that out there. Okay, vertical angles always exist. But I have the O's the same, the X is the same, and the side here. So that's angle, angle, side, because the side is not touching both of the angles. And then here they're just looking for us to give corresponding pieces. So you can go in any order for the first triangle. So I went DEC, but you could have done CDE, DCE, etc. Okay. But because I went DEC, D corresponds with N, E corresponds with M, and then C corresponds with itself. So that is where you have that. And again, these vertical angles always exist, just reminding you of that. And the next one, this is called the reflexive property. So does everyone see, I'm hoping, that CE is a part of the left triangle and CE is also a part of the right triangle? That's called the reflexive property, when something is congruent to itself. So because CE is the same as itself, we can say that it's equal. I always like to think of, you look at yourself in your reflection, so that's where reflexive property comes from. But it's that shared side. You need to know that these two things, vertical angles and reflexive property, are the only two things you're allowed to assume from a picture, and you will be using them a lot. So we have two angles and a side. The side is in between those two angles, so it's angle, side, angle. And then again, we put the two, don't know what happened there. We put the two congruent statements up there based on corresponding pieces. All right, letter C. So I have two sides, I have two angles, and there's that reflexive property again, this shared side CE. So I have a side, and an angle. The angle is in between the two sides, so it's side, angle, side. And again, we're making DEC congruent to TCE. You're just going in corresponding order. Okay. Next one, I have a pair of sides that are equal, a pair of sides that are equal, and a pair of angles that are equal. So you might be saying, okay, great, side, angle, side. But remember, the order matters. This angle is not in between the two sides, so this is a no. Same thing for letter E. I have 3 pairs of angles. That's another one that does not work. So how do we actually write these proofs? Well, you do it the following way. You have givens, and then you have things that you're allowed to assume from the picture. A reminder, you are only allowed to assume reflexive property and vertical angles from the picture. So first you start by labeling your givens. So angle BDT is congruent to angle GDT. So I'm going to mark those. So BDT, I made an arc. GDTD, I made another arc. And then I'm going to label my next given. BD is congruent to GT. So I have those labeled. What you need to remember is that for all of these, except HL, for all of these you need 3 pieces. I only have 2 pieces right now. I have a pair of congruent sides and a pair of congruent angles. So I need to look for more. Once you're out of givens, it's almost like a procedure that you're going to follow, okay? Once you're out of givens, you always look for reflexive property or vertical angles. Always, always, always. In this case, I have reflexive property. TD is a shared side here. It's equal to itself. So now I can write my proof. I can see that this is going to be a side angle side proof because I have a side with an angle in the middle. If it's easier, kind of cover one of the triangles up with your hand so that you can just focus on one triangle if that makes it easier to tell that it's side angle side. And now we write it. So again, we have to say everything that they gave us. So we have to say angle BDT is congruent to angle GDT, given. Again, we have to put our other given in. But this is only 2 of the 3 pieces we used to say that the triangles were congruent. We also said that TD was congruent to itself because of the reflexive property. And then from there, we can prove what they're asking us to, that the 2 triangles are congruent, and the reason being side, angle, side. So this is how a proof is always going to flow. You're going to have your givens, some other information, and then you're going to prove with side, angle, side, 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 one of those. So let's do another example. They're giving us angle B congruent to angle D, so I mark that. They're giving us AC congruent to EC, so I mark that. I'm out of givens, and I've only used 2 pieces of information, so I need a third. Again, you always look for vertical angles or reflexive property. It's the only thing you're allowed to assume from a picture. In this case, we have a pair of vertical angles. So I start to write my proof. I have my given, my reasons given. That was told to me. Again, I have my other given. It was given to me. I now know that angle ACB is congruent to angle ECD. I cannot say angle C is congruent to angle C because I don't know which one you're talking about. What you could do is put the number 1 and 2 in there and say angle 1 and angle 2. Okay, but either way, we knew that because of vertical angles. So we say vertical angles are congruent. You can absolutely use the symbol for congruent in your proof. Okay, again, if you didn't want to do all 3 letters, you could put a 1 and a 2 in here and call that angle 1 is congruent to angle 2. As you get more used to writing proofs, you're probably going to enjoy doing the 1 and 2 better, more, just because it's a little bit easier. And then I can say that the triangles are congruent because of angle, angle, side. Again, if it's easier, cover up one of the triangles with your hands. Just focus on this triangle. I have 2 angles with a side. The side is outside of the 2 angles, so it's angle, angle, side versus angle, side, angle. Number 3, we're given, and I'm just showing you can write both your givens together if you want to. So that's what we're given, and we label. So I'm given those pieces. That's all I'm given. I need a third piece, so I look for reflexive property or vertical angles. In this case, I have reflexive property, that's shared side, and I write that in my proof. So AC is congruent to AC. And then I can say that the 2 triangles are congruent because of side, side, side. In number 4, I'm given angle B is congruent to angle D. Next, I'm giving something different. I'm given an actual definition. So we're going to do this a lot more in another video, but I'm just kind of introducing it now. As you first start to practice, you're going to be practicing proofs very similar to 1, 2, and 3. But okay, so if C is the midpoint of AE, so C is here, I know that AE, C is in the middle of it. So that would mean that AC was congruent to CE. So now I have all of my givens marked on my graph, or excuse my picture. And then I also have vertical angles, which I can label 1 and 2 if I want to. So I write my given. Now what you have to be careful is you can't jump to AC congruent to CE. You have to say your other given. So you tell me C is the midpoint of AE because it was given to me. But that wasn't it, right? That doesn't say anything's congruent. We did something after that. So anytime you have a vocabulary word in the given, you have to then apply that vocabulary word. So AC is congruent to CE, and we knew that because of the midpoint. So that's definition of midpoint. From there, I have 2 congruent pieces. I need a third. So I'm going to say that the vertical angles are congruent. And then I can say that the triangles are congruent because of angle, angle, side. Again, I have 2 angles with a side on the outside, so this is angle, angle, side, not angle, side, angle. Proof 4 should feel a little bit uncomfortable because it's the first time you're seeing proofs and I threw a definition in there. But proofs 1, 2, and 3 are where you're going to be practicing to start. Have a great day and I'll see you in class.